Okay, so we proceed to the next question, question 5b. Question 5b, the question reads, the k of y is equals to x squared. We have y is equals to x squared plus 4. So the k of y is equals to x squared plus 4 is rotated one revolution about the x-axis between the limits. We have the limits x equals to 1 and x equals to 4. These are the limits that this curve axle has been rotated on one revolution just. Okay, so the question says determine the volume of solid of revolution produced. They want the volume of the revolution produced when this curve it was being rotated. Okay, so what we are supposed to do and what it's supposed to come in our mind about when you read such kind of equation or when you come across such kind of equation, you've been given the limits. These are the limits that you've been given, and when it comes to this part, trying by all means to solve the question which has been rotated or which has been rotated one revolution on the x-axis or the y-axis. Of course, we use integration, but it has the formula for us to come up with the volume. Okay, so what they're trying to come up with the volume, here is the formula that you are going to be using. If the rotation it was being made, if the rotation it was being made, if the rotation it was being made actually on a curve which is on the curve which has the equation of y-axis, the volume that you're supposed to calculate, if it was being made on the rotation of y-axis, the formula that you're supposed to use for you to calculate the volume, it's supposed to be v. Remember, it is on the y-axis. So if it is on the y-axis, meaning you're supposed to differentiate with respect to x. But if it is on the x-axis, you're supposed to differentiate with respect to y. So if it is being rotated on the y-axis, this is the formula that you're supposed to use. V is equals to the integral of those limits being given. I'll use D and E. Let me use D and E. I'll use D and E. These are the limits you're supposed to use, D and E. Then remember that we are dealing with the radians. So it will be the rad of, since here that the equation that we are dealing with, we're supposed to integrate it with respect to what? To x, since it is being rotated on the y-axis. So since it is on the y-axis, you're supposed to differentiate with respect to x. So it will be v is equals to this integral. Then we have our y, because we are differentiating it with respect to x. So we're going to have y squared dx. We have something like this, since we are differentiating it with respect to what? To x. But if we are differentiating it with respect to y, it will be v is equals to, I'll use the same rule, limits, dE. Then we'll have pi with respect, this one it is respect to y. So we're going to have our x squared dy. We differentiate it with respect to y. These are the formulas that we are going to use. So we proceed. In this case, here it is our equation, and we are differentiating it with respect to what? With respect to x. So since we are differentiating it with respect to x, this is the formula that we are going to use here. Since we are differentiating it with respect to x, we proceed. So what you are supposed to do is try by all means to come up, since this is the equation, try by all means to come up with a curve. Since this the question says the curve of y, the curve of y is equals to x squared plus 4. Let's try by all means to come up with a curve. We have the limits. We have our x here, we have our y here. Okay, this. So we have something like this. What is our x? Our x have been given that it is the limits. The limits from 1 to what? To 4. So from 1 to 4, that's the limit that you've been given. So from 1, it will be 1, 2, 3, and 4 itself. From 1 to 4. This is the limit. Okay, let's try to come up with the values of y. Okay, so for us to come up with the values of y, we've been given the equation. We have y is equals to x squared plus 4. How do you come up with the values of y? Where there is x, you'll be substituting. Where there is x, you'll be substituting with these values here. Then you come up with the value of y. Simple. So what is y squared? What is 1 squared? That's 1. What is 1 squared? That's 1 plus 4. That's 5. Eh? 2 squared, that's 4, plus 4 becomes 8. 3 squared, that's 9. What is 9 plus 4? Becomes 13. 4 squared, that's 16. 16 plus 4 becomes 20. Okay, so you have something like this. Okay, so you can plot now this. You can come up with your graph here. Okay, this is your graph here. You have something like this. Okay, why am I not including the negatives? Because we don't have the negatives here. So it will be 0. X part I have 1, 2, 3, and 4. This is my x. Okay, what is the y part? I have 5, 8, 13, and 20. So I'll have 5 here, 8, 13, and 20. Okay, I have these as my values. So what is 1,5? I have here. What is 2,8? 2,8 to come here. What is 3,13? 3,13, it will be here. This. Okay, what is 4,20? I have something here. So my curve, it was coming like this. Okay, this is my curve. So this is my curve. Okay, so I have something like this. This is my curve. So this is the limit. So they want us to calculate this volume here, the one I'm shading. Okay, they want us to calculate this volume here. So how do you calculate this volume? The one that I have shaded. Okay, so using this formula here, because we're differentiating it with respect to what? To x. So using this formula here, we are going to have our v is equals to the integral. What are the limits of being given that it is 4 and 1? So we're going to have 4 and 1 pi open bracket. So what is our y? The function of y here, being given that it is x squared plus 4. So it will be x squared plus 4. Remember, it is what? It is squared. You put your square here as well. D what? Dx. You have something like this. We forge ahead. So it will be v is equals to the integral, don't forget, of these limits. So it will be our pi open bracket x squared plus 4. So what they mean is you have your x squared here plus 4. You close x squared here plus 4. Okay, x squared times x squared, that's x raised to power 4. X squared times x squared times 4, that's positive 4x squared. 4 times x squared, that's positive 4x squared. Plus, what is 4 times 4? That's 16. So we're going to have something like here, x raised to power 4. What is 4x squared plus 4x squared? That's positive 8x squared plus 16. So you have something like this here. With respect to what? With respect to x. When you reach this stage, meaning the matter has ended. So just the matter of now replacing. How do we substitute, or how do we replace? So we continue. Our v is equals to, since we have these limits, okay, so it will be just substitute. Where there is x, you put what? 4. So it will be 4. Where there is x, you'll be placing with what? With 4. So it will be 4. Sorry. Before we start substituting, we have to integrate this, because there is an integral here. Yeah, you have to integrate this first. So when you integrate, that is x raised to power 4. The integral of x raised, when you integrate x raised to power 4, becomes x raised to power 5 over what? Over 5. Okay. Plus, when you integrate this one, remember, integration is just you adding each and every power plus 1. So what is 2 plus 1? That's 3. So 2 plus 1, that's 3. So 3 as a power, even down, to be 3. So it will be 8 over 3. Remember how we differentiated in the previous videos we had. So it will be 8 over 3 x raised to power 3. Plus, when you integrate, the constant becomes 16x. When you integrate the constant, just include the x or the omega t or the what that you're going to include. So this is the integral of what is inside here, raised to power 4 and 1. Okay, you have something like this. Now then you start substituting now. So it will be where there's x, we place with what? With 4. So it will be 4 over 5 raised to power 5 plus 8 over 3 raised to power 3. So plus, so this one to be 16. So it will be 16. Oh, here we forget to include the 4. Sorry. So to be 8 over 3, 4 raised to power 3. So here to be 16 yeah, open bracket, we have our 4 here, we close, minus, remember, now we come with the 1 part, so it will be 1, where there's x we substitute with 1 raised to power 5 over 5, plus 8 over 3, 1 raised to power 3, plus 16, open bracket 1, that's all, we close. We are done with this part. When you reach this part, what next? V is equals to, so now here on the calculator, when you punch this, what is 4 raised to power 5, you divide it by 5, you get 204.8 plus 204.8 plus, what is 4 cubic, that's 64, by 8, you get 512 divided by 3, you get 170.67 plus, what is 16 by 4? Wow, that's what, 64. You have something like this, okay, something like this, minus, what is 1 squared, what is 1 raised to power 5? 1 raised to power 5, that's 1. When you divide it by 5, you get 0.2. 0.2 plus, what is 8 divided by 3? You get 2.67. Okay, what is plus, what is 16 plus, what is 16 by 1? That's 16. Okay, so you have these figures. So what next? Since you have these figures, what follows is just trying by all means, you add this, and when you add this, the total that you're going to find this side, you substitute from this point. Okay, so this is what I mean here. Okay, so we are going to have our V equals to, so now the previous figures we had this. Okay, we had this. These are the previous figures we had. What is 20? Sorry. What is 204.8 plus 170.67? 170.67 plus 64. We are going to have 430. We are going to have 439.47 47 minus what is 0.2 plus 2.67 plus 16. We're going to have 18.87, something like this. Okay, so remember here we have our pi outside. Don't forget the pi. Okay, so the final answer, it will be, what is 439.47 minus 18.87. We're going to have 420.6 pi. You're going to have 420.6 pi. But this, the 420.6 pi that you have, we're having, if you want, you can multiply it. If you want, you can multiply it. So it will be, when you multiply by pi, what is 420.6 by pi? You're going to have something like 1321.35. But anyway, even at this point you can end. Then remember that since it is we are dealing with the root mean square value that we are dealing with. Since it is the root mean square value, the units that you're supposed to use, they're supposed to be in cubic. Root it is root mean square value, and we've been told to do what? Sorry, not the root mean square value, but the volume. Yeah, sorry. The volume that we are calculating. Since we are calculating the volume, we all know that the volume, it is cubic, and when you are dealing with the area, it is squared. Since you are dealing with the volume here, you're supposed to put the cubic value. So here the unit, it will be cubic what? Cubic unit. So you can write your cubic unit here, or you can have your 420.6 pi unit cubic. You can have your cubic unit here. Unit, you can have something like this, or you can just have this. So this is our question 5B. We'll proceed to the next question.